Okay everyone, so I'm just gonna show you a demonstration of my first time made robot. I mean it's the first, I don't know how it's gonna work, but I'm just recording it for the first time. Anyways, by the way, this is my lab. It's in Mackenzie building in Carlton. Some of you may know, but some of you may not know. Anyways, this is my lab. It's quite messy, but I love it because I can find stuff at least, easily and all that. Anyway, so that's my lab. That's a robotic chess. Anyways, that's my professor built it, and it's pretty sick. So that's my lab, and this is my robot. And just this is the main thing. Basically, it's the handy board robotic controller built by the Massachusetts Institute of Technology, MIT, and it's just a car assembly. You can find it anywhere. Anyway, so right now I'm programming it with just 10 to 15 lines of code. Um, enough to go forward or backwards, just to kind of test. Okay, so over here I have this. It's currently switched on. If you can see, if you can read, it says IC 4.30. IC is basically the language in which this handyboard should be programmed. It's interactive C. It's different from C++. I mean, one of a kind, same commands. I mean, not same commands, same logic, same syntax, but different commands. There's, for DC output, there are different commands and all that. Anyways, so I've connected this controller to my computer via this RJ11 connector, and this connector goes into the interface, and this is the serial connector. This whole thing is the serial USB interface, which means that there's a serial connector, and then it connects to the USB, and then that USB goes into my laptop. And so I'm currently programming it to go just forward and then backwards, right? So that's my code, if you can see. Anyways, you don't need to see the code. Let me just download this code onto my handyboard. It's pretty sick. Frankly, I still don't know what these four bridges are for. These four bridges. I still don't know what these edge bridges are for. I haven't even studied that. So these are the ports. First of all, these are the DC output ports. I can connect it to any DC output, like motor over here. This is DC motor, right? So I've connected this DC motor to here, which drives the wheels. And then these are the serial ports. This is these ones are the digital ports. I can connect any digital sensor into it, and then it returns me a value. And then it returns me digital value, like 0 or 1, right? True or false. For example, infrared sensor, and not infrared, but like micro switches, right? Micro sensors, microprocessors. Those kind of digital devices. These are the analog ports, and I can connect any analog device to these number of ports. And basically, and these ones, the middle sockets are the ground. So basically, you have to ground every device because this is a controller, right? And then this one is the infrared. Now this is the most fancy thing in this, because it connects. I can connect since it's just one, I can connect only one infrared sensor into my controller, and that infrared sensor would detect any obstacle in front of the robot, right? And that's my further plan. After this testing, I'll be moving. If I'm successful in this testing, I'll be moving over to the infrared thing. What I'm planning to do, I'm adding 2 infrared sensors, and that's why I'm changing the board too, because this has just one port, right? And I need 2. I'm putting one on the left front and one on the right front, so that it can detect obstacles on a wider range in front of it, and then it returns the values, and it's just true or false, and then I have the programming thing. So this is pretty sick board, right? Anyways, and so I've downloaded the code from my computer to the robotic controller. right? And I think it's all done. The speed on the motors is actually to maximum, so it's all done. It's the time to check now. So I take out my USB, turn it off, take out my RJ11 connector. So there it is on its own. Anyways, I'll be the way it's gonna communicate through the controller or host computer is through a network called Zigbee. First I was using Bluetooth, but then Bluetooth wasn't giving me enough range, so I'm changing to Zigbee network, which is quite pretty fast, which gives me pretty large bandwidth. This is the Bluetooth device that I plugged it into my robotic controller, and that was sending Bluetooth signal to my dongle. Now where's my dongle? Here's my dongle. So this was my Bluetooth dongle, a kind of USB again, and everything is USB. So okay, so now I turn it on. Now let me just fix the screws in there. The wheels on this card is pretty easy. I mean, it can turn, in any direction. I don't know. I haven't programmed it to turn yet, but it can turn in any direction, so it can land at any place. I don't know where would it go. Anyways, let me just keep it here. Okay, so I programmed it to move. After 20 seconds, I turn on the power button. Like, I turn it on. After 20 seconds, it will move, right? So here is my switch. So the controller is on, and let's just wait for 20 seconds, and then it should go automatically. It should go in forward direction, and then it should go in backward direction. Wait. There you go. Wow. Wow, nice. Let's just turn it off. Let us just give it one more try. Kind of need a big area. This is small. There. No. It's going like that. So I should put it here. Yeah. So let me just again fix the screws because it's loose, because I'm always programming it, so I haven't fixed it yet into its rigid body. Okay, there you go. And I'm putting it here, right on the door edge. Okay, so I turn it on. The battery power is there, so we should go in a good direction now. There's a lot of free space in here. Let's clear it up. I have to clean the lab, so let's see. If you can see, there's a blue light which says power. Wow, beautiful. Nice. So there's my little robot just programmed to go forward and then backward. I program it to do more stuff, and then I'll record one more video. Thank you for watching. Bye bye.